Okay, we're going to go into notes on 12-3. We're going to talk about an inscribed angle. But actually, before we get into what an inscribed angle is, we should be reminded of what a central angle is when you are from the center. This angle here, 90 degrees, it hits an arc. This arc, which we will describe as an intercepted arc, is also 90 degrees. So the center angle is equal to the arc. I shouldn't just put 90 degrees. It could be equal to any degree, but it's in this particular one, it's equal to the arc. What we're going to see today is called an inscribed angle. And an inscribed angle is not in the center. It is backed up, and it will be on the circle somewhere. So I'll just put a point there. And when you're on the circle, you'll be considered an inscribed angle. And let me just draw this picture here. I'm going to be hitting the same arc, AB, there in yellow. So this is what we would call an inscribed angle. It is literally on the circle. And it's clear that this is not 90 degrees. Even though this yellow arc is 90 degrees, same as the central angle, this is not 90 degrees. And in fact, we will go on to see that it is half the arc length. So if it's 90 degrees out here, then this would be a 45-degree angle in here. All right, inscribed angle, central angle. So let's go to our notes here. An inscribed angle is not from the center of the circle, it is on the circle itself. All right, so angles, this right here, this is angle C. This is what we would call an inscribed angle. And the angle hits an arc here, and this arc, AB in pink, would be called the intercepted arc. But basically, you'll just hear the book say the arc that it hits and stuff like that. Okay, the formula that I just showed right here, the inscribed angle is half the arc. Angle AB is half of arc, what is this, AC. Okay. And so if this is 80 degrees out here on the arc, then this intercepted angle is half of that, 40 degrees. Or you might have, if this angle inside is 40, you should be able to figure out the arc, which would be double that. There are different versions of inscribed angles. Now I showed one where it's clear that angle B is on the circle and it's clear where the angle is. These are other examples of inscribed angles where the angle C is on the circle, just like angle B is on the circle. One side of the angle is a chord, one side is a tangent line, but it's still considered an inscribed angle. This picture here, here's point C, angle C. This is an inscribed angle. One side of that angle is a chord, the other is a tangent line, but nevertheless, angle C in this picture is 1/2 the arc it hits. In this case, it's going to hit arc BDC. So if that's 100 degrees, then that angle would be 100 degrees. BDC here in yellow. So I'll just throw out some numbers here. If this is 100 degrees in yellow, then this angle would be half of that, 50 degrees. If this is, I'd probably need a bigger number here, 200 degrees here in yellow, then this is 100 degrees here. But this inscribed angle looks a little bit different. This one is obvious because they're both two chords making up this inscribed angle here. All right, and then there's going to be some corollaries based on this inscribed angles, just other theorems based on inscribed angles here. Again, an inscribed angle is literally on the circle. Okay, it's on the circle. So number one here, if you have two inscribed angles intercepting the same arc, then they must be congruent. So if I look carefully at this picture, angle 2 is this red angle. It's on the circle. It's an inscribed angle. It hits this yellow arc. But also, if I look carefully, this angle here, 38, it's on the circle, but it's an inscribed angle, and it hits the same yellow arc. So that means angle 2 and this 38 are the same. Angle 2 is 38 degrees. Okay? This blue angle 38, if I double it, this would be 76. This red inscribed angle would be half of 76. Again, that would go back to 38 degrees. Here's another little idea. An inscribed angle in a semicircle, which is basically half the circle. If you are an inscribed angle like this angle 1 here, and you hit half the circle. How do I know it's half the circle? Because I hit this dot. This is the top half of the circle. Half of 360, an entire circle, is 180 degrees. So it's 180 degrees here to here. And angle 1 here in red is inscribed on it, and therefore it is a right angle 90 degrees. So this is a right angle there. Okay, because that's half of 180. Half of 180 is 90. Finally, there is this one here about inscribed angles. If you have a four-sided figure that is inscribed in the circle, that means four-sided figure will hit the circle in 4 spots. The opposite angles are supplementary. So angle 1 plus angle 3 add up to 180. Angle 2 and angle 4 add up to 180. Now the reason why this formula works is this. Let's take a look at this first one. Angle 1 is right here to here, and angle 1 hits this yellow arc. The opposite angle to that angle 1 is angle 3. Angle 3, if I see where it hits here to here. Together, angle 1 and angle 3 intercept the yellow and the pink, which is the entire circle, 360. Inscribed angles are half the arc it hits. So if it hits the entire circle 360, half of 360 is 180. And the same would be with angle 2 and angle 4. Okay, let's try some inscribed angle type questions. Number 1 here. Find the measurement of x and y. Well, what we're going to do first is just figure out all of the angles on the outside, and then we can come back and figure out all of the arcs on the outside, and then we'll come back and figure out all of the angles in this four-sided figure here. So let's first do this. There is this yellow arc out here. I'm going to figure out what that yellow arc is out there. To go around the entire circle, it's 360. So this one here is 360 minus the 70, because that's a 70-degree arc, minus this 80, minus this 90. And let's see what this is. And this is the yellow arc here. So turning on my calculator, 360 minus 70 minus 80 minus 90, you get 120 degrees. So I'm going to put 120 in this picture here. Oops, I'm not quite on the... There we go. Okay, now I'm going to focus in on angle x and angle y. First of all, angle x. You'll notice it's an inscribed angle. It's on the circle, so it's an inscribed angle. Angle x is equal to the half the arc it hits. Well, what arc does angle x hit? So let's extend the line here. It hits point F. Extend the line here. It hits point D. So it intercepts this arc that I'm using my pencil, and this fuzzy arc. What is the measurement of this arc? Angle x is half of 80 plus 70. Because it hits that entire fuzzy arc, the 80 plus 70 there. I'm going to do this in pen. Angle x is half of 150, so angle x is 75 degrees. Okay? Let's figure out what angle y is. Now I did that fuzzy thing in pencil because I want to erase all of that to help visualize where angle y is. But angle y, it's on the circle, so angle y is going to be half the arc it hits. What arc does angle y hit? So just using my pencil here, I'm extending the line. It hits right here, so it hits all of this fuzzy part here. If you extend the angle out, and this is 70 plus the 120 that I already calculated. 70 plus 120 is 190. So half of 190 is 95 degrees. So angle y is 95 degrees. Okay? Figure out this angles on the arcs, and then you can go inside to the inscribed angles. Let's try number 2 here. Find the measurement of the missing angle and arcs. So we have, basically we're going to figure out not only A's and B, we can figure out all of this. Let's figure out what A is. First of all, you'll notice there's a dot there, which means this is half the circle. Half of 360 degrees, an entire circle, half of it is 180 degrees. If I notice where angle A hits right here and intercepts 180. Angle A is half the arc it hits, and it hits 180 degrees, so angle A is 90 degrees. Kind of looks like it's 90 because it is, okay, because you hit half the circle. Now, we can figure out angle B by a couple of ways. We can look at this angle 32. Angle 32 hits this arc out here. They didn't ask for this, but this would be double 32, which is 64. This line, which is the diameter, cuts through half the circle, so I can go 180 minus 64 to get angle arc B, excuse me. So I could go 180 minus 64 to get arc B, which is, what is 180 minus 64? 116. So this is 116 degrees there. Okay, that's one way to solve it. I can realize that this is 64, double of 32, and then minus it from half a circle, 180. The other way to do this is go, oh, there's a triangle here. All triangles add up to 180. There's 90 degrees. There's 32 degrees. And so this angle here is 58 degrees. This 58 degrees hits arc B. So I could also go 58 times 2, which is also this arc, 116 degrees. Okay, you can figure out the angle within the triangle and then spread it out and get arc B here in yellow.